Hi guys, this is lesson 8.5 and it is called using the distributive property. Today we're going to talk a lot about factors, and it's important to know what a factor is. So factors are things that we multiply together to make something else. So if I multiply 3 times 8 is 24. 3 is a factor and 8 is a factor. If I were to multiply something like a plus b times a minus b equals, if you remember, a squared minus b squared. A plus b is a factor and a minus b is a factor. So we're looking for things that multiply together to make other things. And then we're looking, when we look for common factors, we're looking for things that are common to two different numbers. So let's say we have 3x plus 9x squared. Well, we have lots of factors going on here, but we notice that both of these have a 3, because 3 times 1 is 3 and 3 times 3 is 9. And we notice that both of these have an x. The second one has 2 x's and the first one has 1x. So they both share, or they have the common factor x. They have the common factor 3 and the common factor x. What I like to think about is if you were in a group with some friends and you were all going to chip in some money to buy something, maybe you want to buy something to eat or you want to do an activity or whatever, and you're all going to chip in something and everybody's going to chip in the same amount of money. The biggest amount of money that you can all contribute is the smallest amount of money that one of you has. So let's say you have 3 people and one person has $5 and another person has $10 and another person has $25. Well, the smallest amount, that first person that has $5, if everybody's going to contribute the same thing, then that 5 becomes the common factor. And in fact, it's the greatest common factor that everybody can contribute. Even though one person has quite a bit more money, everybody has to contribute the same thing, and so everybody's going to contribute 5, and that's going to be the greatest common factor. So those are just some words we're going to throw around today. And we're going to be doing something called factoring polynomials, which means we're going to be looking for things that our terms have in common. So let's just look at a couple of examples. Okay, this is an example 1, and we have a few examples here. Let's start with 27y squared plus 18y. If I want to factor this, what I'm looking for is what can each of my partners here, I have like 2 friends, I have 27y squared and I have 18y, and they're each going to contribute something. What can they each contribute? And it will be equal and the same. That will be the greatest common factor. I look at the numbers first. I have a 27 and an 18, and I have to think about what I know about these numbers. 27 happens to be 3 times 9, and 18 happens to be 3 times 6. Oh, look at that, 9 and 6 have something in common. Actually, look at that, both of these, 2 times 9, both of these have a 9 in common. That 9 is going to be the greatest thing that can go into each of those. You need to think about the factors. You could factor them all the way out and list all the factors to analyze it. I generally like to just start thinking about what is the biggest number that we say goes into, divides into the number here. So the greatest number that each of them can afford is 9. 27 can afford 9, and it will have 3 left over because 3 times 9 is 27. And 18 can afford a 9. I'm just going to write it out there one time. And it's going to be 9 times 2. 2 will be left over after it contributes its 9. When we factor, we're looking, this is multiplication right there. And so we are looking to put something on the outside of parentheses. All right. We dealt with the numbers. If I were to use the distributive property here, I'd have 9 times 3 is 27, and 9 times 2 is 18. So I'm on my way to creating something that would easily remultiply back into what I had before. Let's look at the y squared and the y. Well, y squared is the same thing as y times y. So A, in terms of multiplication, has y times y. It has, it's not that it has 2 y's, because it's not y plus y, but it has y as a factor twice. And then 18 just has y, and y is just what it is. So each of them, if we're going to ask them to contribute something equal, each of them could contribute a y. So I'm going to put my y out here outside the parentheses, and when 27y squared contributes a y, it still has a y left behind. And when 18y contributes a y, it has a 1 left behind. And so we don't really need to write 2 times 1 there, but there are no y's left over. So notice what happens now if we do the distributive property. 9 times 3y, 9y times 3y is 27y squared. That's awesome. It goes right back to where we started. And 9y times 2 gives me 18y, and that will go right back. So when we use the distributive property, the distributive property is going to take us back to the original. It's a way of checking ourselves after we factor. So we have taken out common factors, and this right here is called factored form. This right here is called expanded form. That's what happens if we do the multiplication. Let's do example B here. It has a lot of negatives in it. Negative 4a squared b minus 8ab squared plus 2ab. Okay, think about a bunch of friends. They all want to contribute what they can, but it has to be fair and equal. So let's look at each one of these and decide what everybody is going to contribute. So this is one friend, this is the other friend, this is the other friend. So let's look at the numbers. We have -4, -8, and 2. Don't worry about the negatives so much. We can factor out -1, but lots of times we're just mainly focusing on the 4, the 8, and the 2. Notice that 2 will go into each of those numbers, but not anything bigger than a 2, because obviously 2 goes into itself, and that third friend down there, the most it can contribute is a 2. So I'm going to leave or take out a 2. If I wanted to, I could take out a negative. I don't think it's to our advantage. Let's just take out a 2 for now. All right, let's look at the A's. Can each of the friends contribute an A? Yes, they can, because -4a squared b has 2a times a. -8ab squared has an A, and 2ab has an A. So we can take out an A. And can each friend contribute a B? Absolutely, because we've got 4a squared b, we've got -8ab squared, so that one actually has 2 b's, and then we've got 2ab. So each of them has at least one b. So notice that 2ab is the greatest common factor. It is the most that each of them can contribute to whatever it is they're adding up, they're trying to do. So after they contribute, let's talk about what's left. -4 divided by 2 leaves -2. A squared divided by A leaves an A, because A times A is A squared. And then B divided by B, or when I take out that B, there aren't any B's left. So I would just have a 1 left behind there. So if I only have one b and I take out a b, it's gone. And then we'll check this. I'll show you how to check it in just a minute. Negative 8 divided by 2 is negative 4. If the negative 8ab squared contributes its a, the a is gone, leaves behind a 1. And b squared, this one actually had b times b, so it can afford to not only contribute a b, but it has a b that remains. And then look what happens, 2ab. 2ab is going to contribute 2ab. So the only thing that's left is a 1. It doesn't become a 0 because anything times 0 is 0, but anything times 1 is itself. So let's use the distributive property and remultiply this back and see if it worked out. 2ab times negative 2a is going to give me negative 4a squared b. I know some of you are not super comfortable with factors and multiplying with variables just yet, so keep practicing. Negative, or 2ab now, times negative 4b is going to give me a negative 8, because I have negative 4 times 2, and then I have a, and then I have b times b, which is b squared. All right, and then 2ab times 1 just gives me 2ab. So notice that the distributive property is a way of checking my factoring. So this was factored, and then I used the distributive property to expand it and check. Distributive property. All right, so let's move on to some more factoring. Sometimes, this is example 2, and sometimes we have something that's interesting. We have something like this, 4qr plus 8r plus 3q plus 6. If I ask you what can each of these friends, looking at this one, this one, this one, and this one, what can they all contribute that's fair and equal? There's really nothing. Look down there at that 6. 6 has the factors 2 and 3. So it could contribute a 2, but the 3 right here, it can't contribute a 2 because 2 doesn't go into 3. So really we have 4, that could be 2 times 2, right? So 2 is really its only factor 4 and 2. Q and a Q and an R, and then 8R has an R in common with the 4QR, and a 4 probably in common with 4QR. But then we get to the 3Q. 3 doesn't have anything in common with 8R, and it doesn't have anything in common with 6. Oh, well, I guess the 3 has something in common with the 6. But so we just kind of look at this and go, what in the world will we do with this? Well, one thing that we can do is we can put this into some groups. So this is called factoring by grouping. And what we do is we just put parentheses around the pairs that we want to factor. We can do this. So looking only in this first pair, we're going to ignore the other pair for now. We see that 4QR and 8R have a 4 in common, because 4 goes into 4 and 4 goes into 8, and they have an R in common. Each of them has an R. And if we were to factor that out, then we could talk about what's left behind. If 4QR contributes a 4 and an R, what it has left behind is a Q. We can remultiply that to check. 4R times Q is 4QR. And then if 8R contributes a 4, then it will leave behind a 2, because 4 times 2 is 8. And if it contributes its R, it's just done because it contributed it. All right, then we keep this plus sign. Don't let it go away, because we don't have multiplying happening right there yet. And we look at our other group. We look at 3Q plus 6. What's in common there? We have a 3 and a Q, and then we have a 6. The 6 doesn't have a Q to contribute, but the 3 and the 6 could each afford to contribute a 3. If I factor the 3 out of 3q, what's left behind is q. 3 times q is 3q. And if I factor a 3 out of a 6, what's left behind is a 2, because 3 times 2 is 6. This is interesting because look what's happened. Q plus 2 is the same in each of these. And this is really unique because this is all multiplication. 4r times q plus 2. There are 2 factors here, 1, 2. And then 3 times q plus 2 is a factor because it's all multiplication, 3 times q plus 2. So now you have to do something kind of dramatic with your brain. We can look at this and say, 4r times q plus 2 plus 3 times q plus 2. If you look at that as 2 factors, they each have q plus 2 as a common factor. If I put q plus 2 on the outside, this is just like back here when I put the 2ab on the outside, or when I put the 9y on the outside here, or did I do another one? Maybe those are the only 2 I've done so far. Q plus 2 is a common factor here, and so q plus 2 can get factored out. Well, what's left on the inside of my parentheses after I factored out the q plus 2? So let your brain, let me get something here. Let your brain eliminate this and eliminate this, because we're factoring it out, and focus here and here and here. What's left behind is 4r plus 3. Notice that there is no adding here because I factored this out and it goes on the outside of this parentheses. It's kind of tricky. Takes a little getting used to in your brain. So let's do another one. Okay, this is another example in example 2. Suppose I have r, I like this one better, 3np plus 15p minus 4n minus 20. Feel free to stop the video, see if you can do it by yourself. That's always a good thing to do. I don't see a common factor between a 3 and a 15 and a 4 and a 20 all together. And there's an NP and a P and an N and then a constant with no variable. So this is kind of funny. And I have 4 terms, which sometimes clues me into the fact that I'm going to try factoring in pairs like this. We need to be a little careful about this minus right there. And then let's just focus here. Start at the beginning, one thing at a time. Do 3 and 15 have a common factor? Yes, they do. They have a 3. Is there a common n in both of these? No. But there is a common p. So I'm going to put 3p as my greatest common factor. Here are my parentheses. If 3np contributes 3 and p, what's left behind is n, because 3p times n gives me 3np. If 15p contributes a 3 and a p, the only thing left behind is a 5. 3p times 5 is 15p. All right. What is common over to the right? Well, here's a hint. Very often we're looking to match this, n plus 5. Is there something that's common in here that would leave behind n plus 5? Yes, there is. There is a negative 4, because negative 4 goes into negative 4, and negative 4 goes into negative 20. There's not an n because they both don't have an n, so let's try just taking out negative 4. If I take negative 4 out of negative 4n, that leaves behind an n. We can always go back and say negative 4 times n is negative 4. If I take negative 4 out of negative 20, that is going to leave behind a positive 5. I'm being very tricky with my negatives. Negative 4 times positive 5 gives me negative 20. And look what I've achieved. N plus 5 and n plus 5. So that is my common factor. So I'm going to look here and here for my common factor, and I'm just going to write it here, n plus 5. That is what both of these, this factor, or this set of multiplication and this set of multiplication, they're both going to contribute an n plus 5. What's going to be left behind after I factor out n plus 5? Factoring out n plus 5, I have 3p minus 4. Now, I do all this fancy stuff. How do I know it's right? Well, I can use FOIL. So let me get this and we'll just check it all up. N times 3p is 3np. N times negative 4 is minus 4n. 5 times 3p is plus 15p. And 5 times negative 4 is minus 20. Hopefully you've gotten pretty comfortable using FOIL. None of these combine. There's our 4 things, and they should match the one we started with in the beginning. It's just out of order a little bit. The negative 4n ended up in front of the 15p, but that is exactly, it means exactly the same thing. All right. Let's talk about how we can use this to solve equations. We have something called the zero product property. You learned this as soon as you started multiplying by 0. Anything times 0 equals 0. And if I have two things to multiply together, like a times b equals 0, then either a must have been 0, or b must have been 0, or both, because 0 times 0 is 0. So what does that mean? It means that when we have an equation like that, if you didn't get that written down, you can just rewind a bit and pause. 2d plus 6 times 3d minus 15 equals 0. Notice that we have two things, 1, 2, multiplied together, that equals 0. And so I know, remember, a times b equals 0. This is a times b equals 0. We know that 2d plus 6 might indeed equal 0, because that would be 0 times 3d minus 15, and that would equal 0. Or 3d minus 15 equals 0. And if we had 2d plus 6 times 0, that would equal 0. Generally, we're just going to assume that both of them could equal 0. In the rare occasion, only one of them might be 0, but this will uncover two possible answers that D could be. And in a little bit, we're going to see on a graph why there are usually two answers. We'll just save that wonderful conversation for another lesson, but let's practice solving this way. As soon as I have this split into two little mini equations equaling 0, I can just do the things I know how to do to solve it. Negative 3 is a possibility for D, and is a possibility for D. So I will need to give two answers for this. D could be negative 3, and it could be 5. There's another word for this. We call these solutions. We call them zeros because we solve them equal to 0. We also call them roots, and we're going to talk about why that is soon. But let's just get all of these words down here for now. And we're going to uncover why they are solution zero's root in future lessons. Let's solve one more. This is kind of a fun word problem, so I'll tell you and then we'll just do the math. It says Penny is a fox terrier who competes with her trainer in the agility course. If you want to see this, it's on page 497 of your textbook. Within the course, Penny must leap over a hurdle. Penny's jump can be modeled by this equation. H equals negative 16t squared plus 20t. That's it. We don't have a constant. Where h is the height of the leap in inches at t seconds. Find the values of t when h equals 0. So if h is the height and h equals 0, we're talking about what time when Penny is leaping over the hurdle. What time is she at 0 height? So if she is jumping, then we're talking about, this can be our x-axis. We're talking about where h equals 0. Actually, I shouldn't make it an x-axis. I'm going to make this a t for time. T for time. Okay. She jumps up in the air, but when her height is 0, we want to know what time. What time is she going to do that? We'll put our h-axis on there in just a minute. Okay, so what can we do with this? We can factor it. Okay, we know that h is going to be 0, but negative 16t squared plus 20t has its challenges to solve because we have a t squared and a t. But if we can factor this, and we can, look at this. There's even numbers, so I know there's at least 2's that come out of this, and there's a t squared and a t, so there's at least a common t. So we can factor something out of here. Let's try factoring out 4. 4 goes into 16 and 4 goes into 20. So let's take out 4 and let's take out a t because t goes into t squared and t goes into 20. What is left behind? 4 times negative 4 gives us 16 and t times t gives us t squared. 4 times 5 gives us 20 and t times 1 gives us t. So I now have 2 factors. Can you see them? Factor 1 and factor 2. So because of the 0, each of these can be equal to 0. So I could say 4t equals 0. And then I can also say that negative 4t plus 5 equals 0. And notice that I was kind of looking for 2 times anyway because Penny started on the ground. She jumped up to go through a cool ring or something, and she landed on the ground again. So let's solve both of these little equations. Dividing by 4 to get t by itself, I get t equals 0. Look at that. Time was 0 when she jumped. So our whole equation is talking about when she started on the ground and then she jumped up through the hurdle. And then let's finish this. Messy numbers. That's okay. T equals 5/4. And 5/4 is actually the same as 1.25. Since we're talking about time, we'll go ahead and make it into a decimal. At 1.25 seconds, she landed back on the ground. All right. Cool and interesting, we have found 2 times where h, our height, equals 0. So if you saw this on a graph, I'll go ahead and put in a little bit more information for you to wrap your mind around. This is h. So what we see is, here's Penny. She started here. She jumped up. She reached a maximum height somewhere, like she went through the hurdle, and then she landed back on the ground at 1.25 seconds. She went up and she came down. This number right here has to do with the gravity, and this number right here has to do with the force of her jump. These are really cool equations. Notice that it made a little arc. That's called a parabola. We're going to do a lot more with those in the future. So that's one example about solving. I will do one more for you here. If I had, and I'm going to going to purposely use one where we're going to solve something. You're going to practice a lot of factoring where you're not solving anything, you're just practicing factoring. Here's an equation. I've got a p squared and a p, so solving this is a bit complicated, except for the fact that I see that 20 and 15 probably have a common 5. P squared and p have common p. If I take 5p out of 20p squared, 5 times 4 is 20, and p times p is p squared, okay? 5 times 3 is 15, and p times 1 is p, so we don't have another p. All right, I have created factor, factor. So I'm going to make both of my factors equal 0, because when we equal 0, we can use this zero product property to solve. We can make each small piece, piece 1, piece 2, equal 0. Whoops, I sort of cut this a little short. Got excited about talking about the zero product property. Okay, let's finish solving each of these. Divide by 5. P equals 0, so that's my first instance. For P equals 3. Divide by 4. Never let these get you. Just keep the 3/4. P equals 0. And P equals 3/4. Sometimes it's only one of those answers, but very often, and usually in the problems we're solving now, where we have a second degree polynomial, we are looking for 2 answers. This is kind of a cool thing, but when we have this exponent as our highest degree, we are looking for 2 solutions. Solutions are answers. We also call them zeros because we've made them equal to 0. And we also call them roots because they are factors, roots. They're like the roots of the equation. When we factor them out, they're like the roots. There's a little more to talk about there, but I'm going to let you do your practice now. Please let me know where you're getting stuck so that I can help you.